So we started with the equals method, right? What is the use of equals and why should we override it? And if we override it, so equals is one of the methods from the object class, and so is the clone method. So if we override it, then uh, what are the things that we should be careful about? So we also discussed those aspects. So the correct implementation should use this get class and not the instance of. And before you call get class, you should also make sure that it's not null. The instance is not null. So you do that, and then you check for the equality of the state, the objects of the states of the two objects. So here the two objects are one is you get it as an argument, and in this case it's O1, and the other one is this object, the current object, right? So you have to compare the states of these two objects, and if they are the same, then you can say that they are equal, right? So that's the point of the equals method. And the other issue that we looked at is with the subclassing. So if you subclass it, again you have to override the equals, and you can make use of super, but there has to be some implementation that is specific to the subclass. So here subclass had one additional instance variable, which is z. So we have to do the comparison for z as well. So that's the equals part. And then we looked at the comparing two objects. So if you have primitive data types like an integer, so you can use the less than and greater than operators and equal to operators. So, and the Java compiler or the virtual machine, so it knows how to handle the less than and greater than operators. But if it's a user-defined data type like a rectangle, it does not know how to handle the less than and greater than. Right? So you need to provide some mechanism to do the comparisons. If you want to, let's say, sort the objects of this particular class. So there are two ways to do that. One is to implement the comparable interface and override the compare to. So compare to takes one argument, and you simply compare your current object, which is this, to this particular argument, which is O, and you can compare it based on the sides or area, so that's up to you. But you have to return these three values, right? So it should, if it's equal, it's 0. If it is less, then it's -1, or it's less than 0. The value does not matter, but it should be less than 0. And if it is greater, so if this object is greater than, say, 0, then it should return a positive value. There's also a second way to do this comparison, and that's the implementation of the comparator interface. So this is the comparable and this is the comparator. So comparator has a method called compare. So, and it takes two arguments. So in this case, it's simply the idea is to compare these two arguments, R1 with R2, and it's up to us on how to compare, right? So, but it returns, we should return the integer value, either 0 or less than 0 or greater than. So that's the other mechanism to make the comparison. So the last one that we have seen is copying objects. So how do we clone different instances? And we do that using clonable interface and overriding clone. So you implement the clonable interface, which is the marker interface. You override clone, and you call the super.clone. So last point is, if there are any non-primitive data types, such as here, it has a list. So you should ensure that you do a deep copy, and you do a deep copy by creating new instance and copying just the values and not the reference, right? So that's a recap of the previous lecture topic. So are there any questions so far? Okay, so let me go ahead with this particular topic, which is generic programming. So in this topic, we will see what is generic programming and why do we need that and how do we implement it, and what are things that we should not do when we are doing generic programming. Right? So let's start with the need. Right? So why do we need this generic programming? So let's say you have a data structure. In the previous example, we have seen this list, right? So we want to say there's a list, and list now stores different types of values. So there's a list for strings, there's a list of integers, there can be a list of floating point numbers. So how do you make sure that these different lists are present? So for example, there is one list that stores only strings, and there's a one list that stores only integers. So but rest of the operations on these elements, they remain the same, right? So that's what we call a data structure. So it has some data, and the operations on the data remain the same. So even though it's a string or an integer, you still want to add an element to the list. You want to get the element, a particular element out of the list. You may want to concatenate one list with the other. You may want to remove all the elements from the list. So all these operations are independent of the data type of the elements, right? So whether the type of the list, sorry, the elements of the list can either it can be integer, float, or whatever. All the operations that I mentioned just now, they can be used on these different data types, right? The operations remain the same, but the type of the elements can change. Right? So that's the um, issue that we are facing. So we have one data structure, but it can take in different types. So how do we implement this? So with the uh, topics that we have seen so far, one way to implement that is using this object class, uh, and because object is the parent for all classes, right? So if you say that something is of type object, then you can throw anything into that list. So let's say we have a list of type object. Um, so you created this list, and now you can add any object to it. So any object instance, so you can add any instance of type object. So this object can now point to either a string or an integer or a floating point number or anything else, right? So it doesn't matter as long as it's of type object, which is the case by default because all the classes inherit from object. So this works, and you are also retrieving any particular element of this list using the get operator or get method. But the issue here would be every time you retrieve it, you need to typecast it, right? Because element 0 can be a string, but which is the case here, element 2 need not be a string, it can be an integer, and element 3 is a floating point number. So you cannot use the same typecast uh, for all the elements, and that's the problem that we face, right? So every retrieval needs to have a typecast, which is not very friendly, and there is no error checking in the sense that you cannot know beforehand whether get of one is a string or a integer or floating point number. You would have to either do this and fail at runtime; it gives an exception, or you have to use the instance of operator or get class method to check for the type. But in any of these cases, it's very cumbersome, right? It's unfriendly. It's not programmer friendly. So we can go and look at a different model, which is the approach to. So in this one, we started checking for the type before we typecast it. So here we are checking if it's an instance of string, and only if that is the case, we are typecasting it. So if it is not of type string, we don't typecast it, and in that way we can avoid this error exception, right? Class cast exception. Um, but again, so the issue with this is you need to keep writing lots of ifs. Let's say this list has 100 elements, which are of different types. So you do not want to write 100 if statements, right? It's very cumbersome and it's not friendly at all. So that's an issue with this approach. So let's go with the third approach, where we create different lists for each data type. So you want a string list, so create my string list, which is separate from the integer list, and this is separate from the type X. So type X can be any type, right? So like a car, bike, person, etc. But the issue here is you are duplicating the code. So all the operations that work on these elements, they are the same. So you keep repeating these operations in each class, which is not useful, right? And yeah, so if you do that, you can obviously have multiple lists which are of different types. So there's a string list, there's an integer list, and so on. But again, this is not friendly because you need to create one list for each type. So let's say if there are 10 lists of 10 types, 10 different types, you end up with 10 different classes. But again, and the functionality will get replicated, right? So, and if you happen to change one of them, let's say you want to make add, I know you want to make some minor modification to add. Now you need to do the changes in all the different classes of this list, which is not a good way. So the solution here is, so these cases are handled by what is called as generic program. So only the type changes, but the underlying operations and then the container, so to say, does not change. So that is what is called as generic program. So that's the motivation. And let's look at another example. So here you have a mug. Now the mug can hold any type of liquid. It can be a tea, it can be a coffee, or it can be any juice, fruit juice, or a soup. It doesn't matter. And the operations remain the same. So here the operations can be pouring liquid into the cup, drinking from the cup, and so on. Right? So the basic operations remain the same. It's just that the type of the content is changing. So this is what is called as a generic cup because it can hold any liquid. And in the the notation that we use here is a cup angular brackets of type T. So T can be now any type. So tea can be a coffee, it can be a tea. So you can pour, milk into it or soup into it or any liquid into it, right? So that's what is the essence of generic programming. So are there any questions so far before we proceed? Okay, so if there are no questions, I'll go ahead. Right? So cup here is what is called as the generic container. So implementing generics is pretty straightforward. So you already know how to create a class and define it, right? So you do it the same way, except that you follow the name of the class with these angular brackets and the type. And there can be also multiple types. So this is a container that can hold multiple different types, or it can be of one type. So we'll be looking at some examples of both the cases. And so whenever some client, so let's say you want to make use of this particular class, it can be, let's say, person or employee. You should specify the concrete type. So here it can be a generic type. So you just have to refer to it by, let's say, T or E or whatever. So some placeholder. But when you are instantiating it, you need to specify the type. So it can be of type, say, string, integer, float, or whatever. And within this particular class, you can refer to it by the variable that you have used. So if you are calling this as T or E, then you can use that same name within this particular class. So we'll look at this example. So the advantage with this is we don't now have to have multiple classes saying that it is a list of string list, integer list, and so on. So we do it this way. So you have your my generic list, which is the class name, and it's followed by these angular brackets and T within it. So you can have any letter here or any name actually. So it can be TE, but generally it's preferable to the convention is to use single letters, and the most popular one is T, which refers to type, right? So assume that for sake of simplicity, you can just assume that it is an integer. So you are saying that my generic list is of type integer, and the array list is type integer. And when you create a new list, it should be of type integer, right? And you add an element of type integer, you return an element of type integer, and so on. So wherever required, you can use the same type name, which is T in this case. So it acts as a placeholder. So let's see. So for the previous example where we created multiple different strings, right? So you can simply have. So if you make this generics, so to say, so you can replace that at the time of defining it. So you can say that it's of type string. So all the elements of this list will be of type string, and all the elements of this list will be of type integer.
Excuse me, sir.
Yes.
Am I audible?
Yes. Yeah, you are audible.
So, yeah. So my question is, so there might be some functionalities that are different to string and integer. Like, let's say I don't have an dot equals method in an integer, right? If I'm not wrong, like string dot compare or string dot equals. So then, would it throw a runtime error or would it throw a compilation error? That I'm not allowed. Like, if I'm using that functionality in my generic list, so what would it tell me? Like, would it be a runtime or a compilation error?
No. So your my generic list will have operations on the list related to the list, right? Not related to the string.
So like let's say if I in public void add to, if I write t, I will only add it to the list if my, let's say, if t begins with an s. In this, okay, I got it. My doubt is in sense.
Because
Yeah.
everywhere here you are
In,
using T. It
yeah.
cannot be a mix.
Thank you so much, sir.
Huh. Okay. So now you have your main where you can create different types of lists, say string and integer. You can add the elements. So it's the same add, right? You are not replicating this operators or sorry operations multiple times. So in the previous example that we have seen in the slide, uh, so here we are replicating the same functionality in multiple different classes. So that can be avoided, and it's much more user friendly or say programmer friendly. You simply have one class and it can take any time. And it's also possible to create a generic class with multiple different types. Uh, say T1 and T2 in this case. Right, so you have your it's what is, let's say the name of the class is pair, and it takes two types which are not known. So these two types can vary. So for example, it can be string and integer, integer and integer, or integer and string, and so on, right? So you have a key and a value. Key is of type T1, value is of type T2. You are making the assignment in the constructor, and there are get and get values for key and value, right? The getters. Okay, now let's come to the main. So when you are creating an instance, you should definitely supply the type. So let's say we want to create a list of pair. So that's why my generic list will now contain pair. So every element would be of type pair. Right? So that's why this goes in here. And in terms of the addition, you are adding each element would be of have two parts. One is the key and the other one is the value. Right. So we are adding keys and values to the DB instance. So what do you think is the case? So is this correct? There is a problem here, right? So if you go back, when we are creating an instance, we should definitely specify the type, data type. So for my generic list, we are specifying the type as pair, but pair itself has generics, right? So T1 and T2. So you need to specify the type of T1 and T2 in this particular case. So this is how you do it. String comma integer. But again, there are some issues with this, right? So on the left hand side, you see pair. It has two instances. Sorry, it has two generic types, T1 and T2, and you have specified the type here. But on the right hand side, you have not done that. So it's important to do that on both the sides, right hand side and left hand side. Yes. So this is how you do it. So you say that my generic list is of type pair, which in turn is of type pair string and string and integer. Right? So is this clear, or are there any questions? Okay, so let me go ahead. So it's pretty simple and straightforward.
Excuse me,
Right? So
sir.
you have, yeah. Sorry, what's the question?
Sir, but while initializing array list, so we can initialize like in that way array list and something like integer int array is equal to new array list. So after new we are not assign if we are not specifying the data types. So in that case we also able to define.
Sorry, I didn't completely understand your question. So after new, we did specify the data type, right? It's important, and if you
Yes,
don't,
sir.
then you will get an error.
No, so maybe saying that when we declare array list of an integer class, we write array list
Oh,
arrow brackets integer.
right,
My
right.
list is equals to new array
Okay.
list. We don't specify the data type on the RHS. So in
Yes,
No,
that
sir.
we
case,
do,
too, it
right?
gets
We do.
initialized.
So we have,
No, even if we don't, it doesn't throw an error, right?
so something like this, is it? Like, so list, so integer, okay. So list integer, say LST,
Is equals to new list, a new array list, right?
new array list, and you do this.
Yeah, with the angular brackets.
Or you do have Angular brackets, okay. And
Yeah.
then what do you specify inside?
No data type.
No, we don't specify anything, but still it works. It gets that the array list is of integer type. We don't have to explicitly mention that.
So if you leave it empty, it works.
Yeah,
That's
yeah,
a
it works.
new one for me. Okay, let me test that. So let's say integer. I think we'll be coming to this in the next class, but yeah, I just want to see. I'll try this. Okay.
I think so. This is a
Right.
modern feature of Java,
Okay.
like, in which it automatically recognizes from the
Yeah.
left hand
So
side.
yeah, that's what I was. right? So I don't think this was the case earlier. It used to complain, I think. Okay, but this is a good point. So let me also check this. Why this is? I think most likely it's the answer that you gave. It's something. I think the type has been recognized based on the left-hand side declaration. But yeah, I can check this and can get back to you. Like when did this change happen? In which version and so on. But okay, let's get back to this. So it's a good practice to specify it on both the sides, on right hand side and left hand side. Okay, so because it becomes clear. So now sort of the instance you don't know what type it is, right? You know the type of the variable that you created, which is LST, but on the right hand side you don't know what the array list should hold. Right? So it's a good practice to just put the data types on both the sides, left hand side and right hand side. So are there any other questions? Okay, so let me move on. So, so the advantage of generic programming is you can write this code which is programmer friendly, right? So now you can uh, have one data structure, say list, that can cater to multiple different data types. So it can be a string, uh, it can be a built user defined data type as well, like say employee, person, car, list of cars, for example. So you can have all these things. Um, and you don't have to replicate, like I said, the functionality in each separate class. I think there was also one more question on chat that I noticed just now. So this is about the usage of Angular brackets, Angular bracket T and just T without the Angular bracket. So if you are using within the class, then you don't need the Angular brackets. So for example, here you don't say private Angular brackets T1. So you say that only when you are instantiating it, right? So when you are instantiating it, you need to specify, because that is the name of the class itself. So the name of the class now has, along with pair, it also has this type information associated with it. So you need to use that if you are wherever you are using the name of the class. So pair here is the name, and pair has two different types within Angular brackets. So you need to use the Angular brackets. But if it is within the class, you don't have.
In the cup example, it was being used inside the class also.
So in the cup,
Yeah, cup, coffee, tea example.
this one,
And the code which comes after this.
I don't think there's a cup code.
Yeah.
Oh, here. Oh, because this is the name of the, so array list is again a built-in class. Uh, and the name of that class itself has this Angular bracket, and there's some type information associated with it, right? So the whole thing is actually the name.
Okay, got it.
So just like your pair. So that's why we had to use Angular bracket. Okay. So let's go to the other question, which is what happens in the background. So how does the compiler handle these different types? So it uses a procedure known as type erasure. Okay, so it will erase the type. So we'll see how it works. So this is on the left hand side, you have your class definition which you created, and on the right hand side you have the erase types. So all the types, whatever is, so T is replaced by object, which is a generic type, right? So object is the parent for all classes, so it can take in any type. So in that sense, it has removed or erased the type, the specific type to a generic type, which is object. Now it will also make sure, so wherever there is T, notice that it has been replaced by object. And the compiler automatically makes sure that whenever you are retrieving let's say elements of it, it will automatically typecast them appropriately. So for example, you have a list of strings and you have 100 of them. So it will typecast all such retrievals. So if you are retrieving 100 strings, it will typecast all of them.
Excuse me, sir.
Yes.
So in this case, my T can be anything. It could be a long, it could be a double, it could be a string, it could be an integer, right?
Right. Right. Yeah.
So now if I implemented my generic list as a list, which when I add something to it, so like let's say if I add 4 to it, it will add 2 into 4 to my list. So it doesn't matter if it's a long or a double or an integer or float. But in the case of a string, wouldn't it give it give an error?
No, why does a string? So a string class, it is a subclass of or a child of object, right? And you can pass instance of a child to the parent class. So sorry, parent instance. Why would there be an error? So here this is equivalent to saying.
I'm asking, like, could you go back to the site, please?
So object O in this case is new string hello. So yeah, that is what you're doing, right?
Yeah, so it's fine.
Huh.
I'm saying in the definition of public void add T O.
Right. Huh.
So if I instead of writing mylist.add O, if I write mylist.add 2 into O,
2 into
so it would work for long, double, float, or int.
no, it would it will compile. Sorry, it will complain here itself. There will be a compile time error. You cannot say 2 into O because so O is not a primitive data type, right? Like it's not int or float. So it's of so you are multiplying in primitive data type with a non-primitive data type. So it will be a compilation error here itself.
Okay, thank you, sir. Thank you, sir.
Okay. So in the first step, yeah, it will erase. By erasing, we mean so replace all the t's, which can be any generic type, with the object. And when you are retrieving it, it will typecast it appropriately. So it will make sure that the typecast always works, right? So for example, if you are if it's a string list, it will typecast as string. If it's an integer list, it will typecast as integer, and so on. So that's how the type erasure works. Okay, so now let's look at a few restrictions while creating this generics, right? So, okay, you have two sets of statements. One is where you are using the regular double. This is the primitive data type. And this is the one with the capital D. That is not the primitive data type. So it's a class that holds double value, but it's not the primitive data type, right? Like you need to create an instance of double, for example. So which one of them is correct? Only one of them is correct. So which do you think is correct? So although in terms of the intention, both are same. So you want to create a list of doubles. So the intention is the same, but syntactically only one of them is correct.
Second one.
Yeah, the second.
So second one.
Yeah, second one, because generics cannot take primitive data types. So in the previous example, right? So T cannot be a primitive data type. So you have to pass in a class, and that's why you cannot pass double, and you can only do that with the capital D double.
Is there any special reason for this?
Because you cannot. So with the type erasure, right? So we have seen it here. So if you want to erase the type, and that's how in the background it handles this generic programs or generics. Only if you have a class, you can make use of the object. If it is not a class, it does not inherit from object, and this doesn't work, right? The whole thing doesn't work. So that's why it has to be of it has to be a class. It cannot be a primitive data type. So for example, double does not cannot inherit from object, but on the other hand, the capital D double, it inherits from object by default. So yeah, so that is a reason for it.
Okay, sir.
Okay, now to the second restriction. So you cannot create instance of type T. So you cannot say, for example, new of T. So it will result in a compile time error, because that the reason for that is the type has been erased, right? So the T has been replaced with object. So there is no way to know what actually T stands for, because it has erased everything. So you cannot have new string, new integer, and so on. So that's why this results in a compilation error.